We finished this example in the last video. Let's move on to this question, which is 2009, number 2. Now, in this question, we're asked to find the velocity reached by a man when he falls from rest from a height of 15 meters until he meets a cushion which is 3.5 meters thick. So we take downward positive. U is 0, S is 15 minus 3.5, which is 11.5, and the acceleration is 10, and we get V equals to the square root of u squared plus 2as, and put in the numbers, we get root 230. So that's about 15.2 meter per second. Now, in the next part of the question, it's given that the man is stopped by the cushion when he is 0.5 meters above the ground, and we are required to find the FH resistive force acting on the man by the cushion. So let's consider the decelerated motion in the cushion. So we take downward positive. U is from part A, V is 0, and the displacement is that when he just touched the cushion, he's 3.5 meters above the ground. When he's at rest, he's 0.5 meters above the ground, so the displacement is 3. So we apply v squared minus u squared equals 2as, and we get a equals to this. Put in the number, we get minus 38.3, and we apply Newton's second law. So the net force is 600 minus R equals ma, and then we get R is about 2,900 newtons. So in part C, the question asks us that if a thicker cushion is used and the man is again stopped when he is 0.5 above the ground, explain why a thicker cushion is better. So let's see. Now, the approach I use here is to generalize part B. So the A can be expressed this way. So then applying the Newton's second law, this is the net force, this is ma, which can be written as minus 30 u squared over s. So moving the terms, we get the resistive force is this expression, 600 plus 1,800 u squared over s. Of course, we want the resistive force as small as possible, so so that the injury to the man will be kept to a minimum. So now using a thicker cushion, we will find that the man reaches the cushion at a lower speed, because the distance he falls before reaching the cushion becomes smaller. And the second is that the deceleration distance or displacement increases, because the cushion is now higher than 3.5 meters, but the man comes to rest still at 0.5 meters. So with the expression so derived for R, look at this expression. U is at the numerator, so when U decreases, R decreases, and also S is in the denominator. S increases, R decreases, so R decreases. This is better for the rescue of the man.